let her meet me after that. Money is not a matter. Most
She is
important.
not saying about money and all. Only that language problems.
So language also we will cover. Don't worry. You say Khushbu ma'am will take it. You first come and start because once they will be coming and learning this, they'll understand what is the most important part here. Then only she can realize.
Okay.
Okay.
At
We
least,
can inspire many
at least
people.
for 1 week, can I ask her to come? And
Yes,
see?
for 1 week she must see that she's understanding or not.
Then we can conclude.
Yes.
Just like trial class.
Yeah, let her tell to come at least for trial classes. If she's coming for trial classes, she's
She's,
understanding very nicely. No?
She will come to a conclusion that we can read in English and Tamil.
Yeah.
But she wrote clear in English only.
Yes, see, once her pedagogy sections and all these are coming very good now, she'll itself be able to go for it. That's the best part. You don't worry, I'll take care of you.
Okay, I'll ask her to come.
Yeah, at least come and meet me once.
Okay.
We can inspire and we can help children.
Okay.
First, we will do physics. Asha is who? Is it Vasant? How is Vasant here now?
Vasant today, yesterday only after school. Tomorrow research.
Okay, Shad, good evening, beta. Good afternoon, beta. Everybody, please pay attention. Listen. Shall we go for our work? Come in. So now listen. First, we will be going for prism. So now look at, we are going to do our work. First work is we are going to do our prism section we have done. Prism section we have done. After prism section, the next part what we are going to we did is about refractive index. Based on that, we have solved some questions. After that, next part is we are going to start. Now mirror we have done. After mirror is coming as lens. Understood? In lens part, if you will be taking in shortcut. See, if we will be taking for this part, Darshani, Sneha, everybody inform in the group. Please kindly tell everyone to join as fast as possible. So now listen, 2-3 things are there. You need to understand first. The first part is कि whenever we will be going for board examination, light chapter science section, we need to do some very important work. Understood. So the some important part here is numericals. The numerical has to be very much clear. Sorry, Maya. Good afternoon. Why you are absent here? Online, offline. Sorry, online you are present. Sophia. Good afternoon. So now look at it. We will start our work rather than wasting time in speaking. We will focus in our work. So refraction sections we have already finished. Light some questions we are going to do. Now let's check this part out. So these are some questions that is old questions and we must do answers are there in the questions. So very carefully we are going to solve this part. Now look here. The questions are, so this is a self-test. Nishant, good evening, good afternoon. Everyone, first lens part little bit we have to study that before going for lens, we will be discussing that part. But here, shall we start the work please? Maximum question coverage we are going to do. The first part is a beam of light is incident through the holes on side A. So this side A, holes are there. Now these holes are exactly allowing the light ray to enter. Carefully see the question. Understood? What type questions are coming and how we are going to check this one out. Okay. Now concave lens. You know that concave lens is diverging and convex lens is converging. Understood or not? Because here one important point to be noted here is कि whenever we are solving these type of questions, two things are having. So mirror, and now we are in a state to differentiate mirror and lens. If somebody will ask you about mirror, and lens, we need to differentiate it very nicely. Lens, sorry. We need to differentiate it very nicely. The most important part is in mirror, concave is converging, in lens, convex is converging. Understood? So here, which one will be diverging?
Convex mirror.
So here, when you will be talking about convex will be diverging and here concave will be diverging. So when the light ray is entering inside, can you see it is exactly splitting? Understood? So inside, what type of box? Inside this box, what is there? Concave lens, rectangular glass lens, convex lens or prism. So some people they are telling convex lens. So let's see, talk about the correct answer is convex lens. But why the convex lens? Understood one? So why should we writing that the convex lens must be inside it? There must be some reason now. So what is the reason that convex lens is inside? It is clear that parallel rays converge at a point. Parallel rays converge at a point and emerge from face B. So convex rays would be possible inside the box. Understood not? So it will converge and then it will come out. So because of that convergence, we can say it is going to be convex lens. Now we are going to talk about the next question. Come on, go for it. Which of the following statement is or are true? A convex lens has 4 diopter power having a focal length of 0.25 meter. Is this a true statement? Come on, go for it. A convex lens has minus 4 diopter power having a focal length of 0.25 meter. A concave lens has 4 diopter power having a focal length of 0.25 meter. A concave lens of minus 4 diopter having a focal length of 0.25 meter. So which answer is going to be the correct answer? Huh? A and C cannot be, two answers cannot be possible. Only one answer can be possible. But here you see convex lens and here concave lens is there. So here concave lens and here convex lens is there. So you need to check very nicely. So here Narain and Darshini has given the option as A as answer. So we need to understand that for convex lens, focal length is minus. Convex lens, focal length is minus. Understood? So now we are going to check convex lens and absolutely the answer is A only. Well done both of you. Now how the answer is A? Let's check this one out. I'm going to explain you another important point. Please check this one out. I told that convex lens focal length is negative. Okay, and concave lens focal length is positive. Remember this one. Write down this one. Focal length for concave lens and convex lens. This is question answer session. This is most important session. Be present in this session. So I am keeping session since morning itself. So today we are going to have a marathon like 4, 5, 6 hours non-stop. Understood or not? So now till 1 o'clock or 2 o'clock, 1:30 we will have this session. Half an hour or 1 hour break. That time I am going to teach 12th standard. Again I will going to start. Understood? So continuously we will do like that. Now this part we have learned that concave lens focal length is positive. But here convex lens 4 diopter. Convex lens focal length is what? Negative. Negative now. But here answer is written as yes. So is it going to be? Yes, absolutely correct answer. Positive sign with power and focal length indicate that the given lens is convex. Understood? So here convex lens. Why? Because see f is equal to 1 by p. It is coming as 1 by 4, 0.25. Did you got this point? Huh? So convex lens 4 diopter power having focal length is this much. Convex lens minus 4 diopter having focal length 0.25. Is it done everyone? Now concave lens has 4 diopter power having a focal length of 0.25. Got it? So now concave lens minus 4 diopter having two. These answers are not true. Now magnification. Can anybody answer about this magnification question? And your time starts now. Come on, go for the magnification question. Finish the magnification question, please, as fast as possible. Come on, go for it. Nicely go. Shall I tell the answer, please, as fast as possible for this answer? Till now, online students have not given any answer, but you people are telling B. Okay, offline children are telling B. What about online children? D. Okay, let's see online children. Nobody answered the question. Magnification produced by rear view mirror fitted in vehicle. Narayan is telling everyone A is less than 1. See, for rear view mirror, there is one statement. And what is the statement? The image, what is appearing, is smaller in size as compared to the distance. Understood? Because the rear view mirror is covering a wider area. Because the image will always be smaller than the object size. Understood? So magnification will be always less than 1. Understood? So the answer is A. For convex mirror is used as rear view mirror and always forms virtual erect diminished. So magnification produced by rear view mirror is less than 1 and magnification will be positive. So please kindly focus into these type questions and do it nicely. Come on, shall we go for the next one? Now we are going to talk about the next part. One by one we are going to do this section. Ready? Now we'll go for the next question and your time starts now. A full-length image of a distance tall building can definitely be seen by using what we can use to see the full-length image. If I want to see the concave mirror, no. Convex mirror, yes. Plane mirror, yes. So both concave mirror as well as plane mirror. Remember this. Concave mirror will be no. Concave as well as plane mirror. Which one you want? Convex mirror, plane mirror, or both concave as well as plane mirror? Let's see. First, let the students can give answer. Everybody please analyze. Rear view mirror now, for these type questions now, take rear view mirror as example. Your most of the question tension will be over. Rear view mirror. Huh? The correct answer is 32 answer. Come on everybody, you people are taking lots of time. See, need to understand one very important thing. A full length image of a distance tall building on definitely be seen by using which type mirror? Convex mirror. Because it will be virtual, erect and diminished. So full size image will be obtained. So here convex mirror has a wide field of view as it forms virtual, erect and diminished image. That's it. So why we are going to talk about most unwanted things? Now we are going to discuss about this question, and your time starts now. The torch, searchlights and headlights of vehicle, the bulb is placed between pole and focus of the reflector, near, very near to the focus of the reflector, between focus and center of curvature, at the center of curvature. So where I am supposed to put, where I am going to put the bulb so that the light will go very far. What can be the position of the bulb so that the light can go very far? What can be the position of the bulb? Huh? Infinity. Image is obtained at infinity at focus. So it should be very near to focus. Everybody please pay attention. It should be very near to the focus of reflector at f. Because at f is the best answer. At f, because you know that if for a concave mirror, everybody last class what video I have made, that video you please kindly see one time, at very near to focus. So last class I made this image, please kindly check this one out. See this one. Okay, this was the situation. So when you will be talking about at f, if you are going to keep that object, what will happen? This will go and it will pass like this, and this will go and pass like this. Understood or not? So this will be exactly, the light ray will be exactly going like this. At f, it will go out parallel. Understood or not? So any rays which is exactly going at f, if it will be going this, it will come out infinity. The light rays will be coming out infinity. At f, it will come out infinity. Am I true or not? Please kindly check one time. So it will be definitely going to be at f, very near to f. So when the light rays, okay, when the light ray, when source of light is placed very near to the focus of the reflector, which are concave shape, the reflected light become parallel to the principal axis. The reflected light will become parallel to the principal axis. Wait, I have gone, I think that way. So if at f you are going to place, then what will happen? The light ray will go parallel to principal axis. Yes, it will cut on focus. Parallel to principal axis means it will cut on focus. It will come like this means it will go like this. This is the situation, but this will not be the case. Understood? For mirror, wait. For mirror, one time I am going to draw it again one more time, because for mirror's position, the position has to be changed. It will come out. It will come out parallel. Yes. So we are going to take like this now. See, that is for image. Point object, if you are going to take means, it will come like this. Like this, reflector. So when the light ray will be coming from focus, it will go parallel to principal. It is coming out, look here, hey, this from focus. When the object is kept at focus, that will come out parallel with the principal axis. Check. Point object is kept at focus, beta, then only it is possible. See, two type of images there. See this. When the object is kept at focus and it is having height, that time it will go parallel infinity. But when the object is point object or bulb, then it will directly start from where this point object is, it will come out parallel. Yes. Did you understand it? So that time it will be like this. So when the point object, see, height is there means no. When point object will be there, everybody pay attention, listen very carefully. Okay, when this is exactly bulb placed here. So bulb placed here means the light source is at focus. So when it will be exactly striking the mirror and come out parallelly. So this is the most important part. It will strike the mirror, it will come out parallel. I hope you might have understood this one. So now, shall I go for the next part? Shall I go for the next part? The law of reflection hold good for plane mirror, concave mirror, convex mirror. All mirror irrespective of their shape. Why? Because this is the correct answer. Always please remember. This is not a small question. Plane mirror, the law of reflection. I told you that time, in the time of giving revision, I have discussed a very important point, and in that point, I have discussed this content that law of reflection hold good for all different type of mirrors, plane mirror, concave mirror, convex mirror, every different type of mirror. The law of reflection is holding good. The law of reflection is holding good for concave, convex, plane mirror, all different type of mirror. I hope you might have understood. So now look here. Can you check this part? First, these two you see. Read the question and first these two cases, because I have to go for the remaining two cases. The path of a ray of light coming from air passing through rectangular glass slab touches by four students, traced by four students as shown ABCD. Which of them is correct? So first we will see that if this person has made in two different medium, there is no reflection exactly, there is no bending is there. So this bending part is not there, so this is not true. Now it is exactly bending, it should go like this, it bend towards the normal, it should come like this, but it went away from the normal. So B looks correct right now. We'll see for C and D, and then again C part is like that. D is again a challenge for us, because now D must be checked. In absence of D, we can't take any decision. So now look here, it is bending towards normal. It was supposed to go like this, bend towards normal. So okay, now here if we are doing, it should go away from normal, but it went towards normal again. So our correct answer is B. What is the correct answer, Naren? Absolutely, the correct answer is B. We will go for, so B is the correct answer. Now come on, go for this question. Huh? Which of the following, the image of an object placed at infinity will be highly diminished and point size? In which of the following, the image of an object is placed at infinity and will be highly diminished and point size? Concave mirror will highly diminished will do. At focus it will be obtained. Convex mirror only, convex lens only, concave mirror, convex mirror, and concave lens. So think very precisely and give the answer for this. Question number 36. Question number 36 is not a small question, yet it is a very defined question, because yes, there are certain cases where point size image is obtained. So when point size image is obtained, you need to be very, very careful. Because listen, in concave mirror also, point size object is made when the object is kept at infinity. Convex mirror also, point size object is made when the object is kept at infinity. But here it is real inverted, here it is virtual erect. Concave lens, it is again virtual and erect, and it is very, very small size. So let's see, D can be the answer, and the correct answer is D. I hope everybody understood. Naren, absolutely correct. The incident ray coming from the object placed at infinity will be parallel to the principal axis when the parallel beam of light incident on mirror or lens, irrespective of their nature, also reflection takes place. I hope you might have understood. So now we will go for next question, assertion reason related question. And your first question is this. Go for assertion reason question.
Both A and B are
Come on, come on, come on. Assertion: incident light is reflected in only one direction from a smooth surface. This is one part. Since the angle of incidence, angle of reflection are same, a beam of parallel rays of light falling on smooth surface is reflected as a beam of parallel light rays in one direction only. This is it, are they asking only for one case, or they are going to symbolizing it for all the cases? You read the statement carefully. Incident light is reflected in only one direction from a smooth surface. Understood? So it is not only reflected by only one direction. For rough surface also it is doing. Understood? But they talked about smooth surface. Since the angle of incidence and angle of reflection are same, angle of incidence and angle of reflection are same. A beam of parallel rays of light falling on smooth surface is reflected as a beam of parallel light rays in one direction. So what we are going to do? We are going to talk about the correct answer is A. Why the correct answer is A? Because assertion reason. Now you check this part. They told since the angle of incidence and angle of reflection are same. Answer: the angle of incidence and angle of reflection are same, and a beam of parallel rays of light falling on the smooth surface is reflected as beam of parallel light, and because of that the correct answer is A. Now we will talk about this one. You check the word ambulance on the hospital van is written like opposite, correct? The lateral inversion. The image formed in a plane mirror are same size of the object. See, a lateral inversion. This correct reason is it is because of lateral inversion. But they have not given the word lateral inversion. Rather than writing lateral inversion, what they wrote here is they are telling that the image formed by a plane mirror is of same size as that of object. That is not a correct answer. Understood? So since the answer is not correct, so what our perspective here is, the assertion is true, reason is true, but reason is not supporting assertion. We'll go for next one. Check. I'm directly cannot see the distant object clearly. Why? The far point of an eye suffer from myopia is less than infinity. So what is the correct answer? This statement is also true. This statement is also true. But this statement is not supporting assertion. So this answer is coming as B. So human eye in colorful world, that part also we are going to talk about. So this part I think it is out of. Right now we are going to talk. Can we start that part also? Because it is all the condition necessary for photosynthesis, because all things are mixed up here. Biology is also mixed here. So we will do one thing, we will go for lens part. Okay, because lens section we are going to discuss one by one. See, now we are going to talk about lenses. So when two spherical or plane mirror will be plane surface are joined together, what they are making? They are making lenses. So lens will have both the side reflecting surface and refracting surface. The light can enter from both the sides. The lenses are shown as below. That is called as convex lens. This is concave lens. This is plano concave. What is the meaning of plano concave? The meaning of plano concave is half. So here what we need to do, check this one out. So here the spherical portion is there now. So if this is the spherical portion and this is the spherical portion, they both will be joined together. What it is exactly making as convex. So when two lenses will be joined like this, what it is making? Concave lens. Understood? Now when half of this part will be there, when half cut part will be there, it will become plano convex. Plano means this is plane part and this part is called as convex. So plano convex. So when half part will be there, like this two conjoint section is there, na? So only when half section will be there, It is called as plano-concave lens. It is called as what? Plano-concave lens. So now lens part, we are going to type of lenses. Double convex lens. So whenever we are using lenses, it is what type? Double convex lens. Plano is single. Two lenses joining together is called as double convex lens. What it is called as? Double convex lens. Now, then the lens is said to be double convex lens or simply convex lens. It is thicker at the middle and thinner at the edges. It is thicker at the middle and thinner at the edges. So this is the definition here. We are going to study definition is what. So here, this part we are going to discuss. This is thicker at the middle and thinner at the edges. Now here it is thicker at the edges and thinner at the middle. This is for double concave lens. If both the refracting surface of the lens are concave, then the lens is said to be double concave lens or simply concave lens. Understood? It is thinner at the middle and thicker at the edges. Now in order to draw ray diagram, in lenses, we need to use two of the following rules. What and all are the rules needed for drawing? A ray of light from the object parallel to the principal axis will pass through the focus. So if any ray of light will come parallelly, after coming and striking, it will pass through the focus. So second, after refraction in a convex lens, it appear to diverge from the principal axis F1. It appear to diverge. What it is? It is appearing to diverge. So now rule 1, can we check? See, this is the rule 1. If you are seeing the rule 1 very nicely, you see this is convex lens and this is concave lens. So in convex lens, if you are watching, the rays which is entering parallel, it will pass through the focus after refraction. Understood? After refraction. And here it is supposed to. So it will come F1, yes, and it will be exactly diverging. Okay. So now here the next part is a ray of light passes through the principal focus will emerge parallel. So if it is passing focus, then it will come out parallel. And if it is about to pass focus, it on the next side it will come out as parallel. Understood? So at the time of teaching in class, I have already explained this one. Now anyone which will be the ray will pass the optical center. What they are going to pass? Optical center will come out without deviation. So this part will become what? Optical center. It will come out without deviation. Like center of curvature was there, na? So here also. So optical center means it will exactly come out like this. I hope you might have understood this part. So when the ray of light will come out, will strike optical center, without deviation it will come out. I hope everybody understood this section. So this is the next part. Now important terms associated with lens. Optical center, already we know the center where 2 points are exactly 2 planar sections are meeting, that center will be considered as optical center. Center of curvature. Here which one is considered as center of curvature? F2 or F1? 2F1. That side also 2F2 will be there, na? Yes. So 2F1 and 2F2. So here now 2 points will be there. One F1 will be there, and here it will be 2F1. Here it will be F2, and here it will be 2F2. Understood? So one time when I am drawing it, please check this one out, because most of the time students are having confusion. So the radius of sphere from which the spherical surface of lens is made is called as radius of curvature. So definitely this part is called as what? Center from this part. So this part will be considered as radius of curvature. Half of this will become focus. Understood or not? Now here they are joining together. This center will become what? Optical center. But rather than writing R, we are writing it as 2F1. Understood? Now we are joining this part with half. So here again if we will write there, this part will be R2, correct? No? So we will write it as F2, 2F2. And this part will become F2. And this one will be optical center. I hope everybody understood this one. F1, F2, 2F1. So radius of curvature means the center part of the sphere will be taken as 2F1. What it will be taken as? 2F1. And here it will be taken as 2F2. Is it clear? and O will become the optical center. So see, this center part is taken as C1 and C2. So this one will become 2F1 and this one will become 2F2. Here also this will become 2F1 and here it will become 2F2. So now we are going to go for our principal focus also. We know how that, see, concave lens and convex lens. If somebody will be asking you about convex lens and concave lens, सी प्रिज्म, अगर तुम अभी मुझे सेपरेटली बोलोगे प्रिज्म क्या होता है, तो प्रिज्म का पूरा वीडियो रखा हुआ है. दो प्रिज्म, 3 प्रिज्म videos is already made. You can go in YouTube channel and check everything. Prism 3 classes we have taken. How many classes of prism we have taken? I have taken 3 major classes of prism. 3 or 4 classes are there. Everything is recorded there. I hope you might have understood this one. Everything is recorded or not? So everything is there. Himanshu, एक बार check कर लो please. Now look here. If somebody will be asking you this section, can we go for it? Now look here. When the rays are coming parallel, it will pass through the focus. So we know that convex lens is converging. Convex lens is converging. Understood? So because of that, and focal length is positive. Focal length is positive. There one mistake I did at the time of writing that time. Now look at concave lens. When somebody will be asking you about concave lens, it is what? Diverging. Understood? So concave lens is diverging. Focal length, the distance of the principal. See, this part is 2F1, OF2, it will become F. This part, the OF1 here and OF2, it will always be focal length F. I'll draw it and write down. So refractive index of material of the lens, the focal length of the lens depend upon following factor. This is an important question. On what factor focal length depends upon? The focal length of a lens depends upon what factor? Note down. The focal length of a lens depends upon what factors? मैथ्स का क्वेश्चन भेजोगे तब ना. हिमांशु, तुमको लगता है मुझे सांस लेने का टाइम है, 2 मिनट मुझे सोने का टाइम नहीं है, तो क्वेश्चन व्हाट्सएप देखने का टाइम बहुत है मेरे पास. See, first radius of curvature of both refracting surface and refractive index of material of the lens. With what the lens is made up of, that is exactly going to decide the focal length. Understood? So radius of curvature of both the refracting surfaces. Both the refracting surface means what? Radius of curvature of both the refracting surface. So this refracting surface, radius of curvature and radius of curvature. So 2F2 and 2F1. So focal length definitely depends upon this. Understand or not? So refracting, both the center of curvature of the refracting surface, the radius of curvature is dependent on. So that's a very important point. Next point is refractive index of the material of the lens. Remember that one because it will determine the optical density. Yesterday, I taught a very important point. Just remember that one. If somebody will ask like, if a ray of light will enter from one medium to another medium, that means the ray is getting permission to enter, then only it is entering. Wall will never enter. Correct, So wall will scatter light. Correct. See, this bottle will never enter. So this bottle will scatter light and it will shine. Either the surface can be shiny or the surface can be dull. But when I will be taking any surface like mirror glass, so like this glass, so is it going to allow the light to enter? Yes. But every material is having its own optical density. And if optical density is maximum, bending will be more. Bending will be more. Refractive index will be high. Speed will deteriorate. Understood not? So there are certain factors yesterday we have studied about lens part. So sorry, the bending of the light and optical density. So refractive index of the material of the lens plays a crucial role. What is playing a crucial role? Refractive index of the material of the lens. So refractive index of the material of the lens is playing a very crucial part. I hope you might have understood. Now we are going to go for the next part. Let's check this one out. To find the focal length, get rough focal length of convex lens. Focus a distant object to a screen using convex lens. The distance between the lens and the screen is called as focal length. This is again another point because most of the time now students are having confusion where the screen should be placed. Where the screen should be placed. So where the screen we are going to place better? A rough focal length if I want. So convex lens of a focus a distant object to a screen. Using the convex lens, the distance between the lens and the screen is called as focal length. So the distance between the lens and the screen. So if I am keeping lens here and keeping screen here. So distance between the lens and the screen, this part will be considered as what? Focal length. I hope you might have understood. Sign convention, conversation. I think sign convention will come. The same rule of sign convention are as that of mirror can be used as lenses. Correct, na? Up means positive, down means negative, left means negative, right means positive. That rule everybody knows, na? Up means positive, down means negative, left means negative, right means positive. So the time below giving the position, nature and right ray diagram of the subject of convex lens is exactly made like that only. Already we had discussion about it. WhatsApp check, Mansi, one time. WhatsApp check. Okay. I hope you might have understood this one. I hope you might have understood better. So whenever the light ray, this is exactly divergence and this is called, these two parts are there now. So the table below gives the position, nature and ray diagram of various subject of convex and concave lens. Correct now? So first work is we are going to talk about concave lens. Usually everyone start drawing please. So concave, good afternoon Ashweta. For concave lens, two reasons are there. I will tell you what and all to write about concave lens. Start writing please. For refractive index related questions, again I have to give. Now look here, lens formula, magnification, both I am going to discuss. Please kindly pay attention till here. Ashwita, good evening. यार अभी मैं पहले क्लास लूँ कि क्या करूँ समझ नहीं आ रहा है लेंस फार्मूला फर्स्ट गो फॉर लेंस फार्मूला what is the lens formula 1 by v minus 1 by u is equal to 1 by f and for lens magnification is v by u positive v by u and height of image equal to height of object so height of image is equal to height of object I hope you have understood this one. Now look here. When we are doing this, I redraw it. So write about concave, convex, concave lens, right? The distance of the object from the optical center U is always negative. So here some points we are going to write. U because when the object is always kept in front of mirror, na? So U for concave lens, some things we must always remember. So since the object is kept in front of mirror, either at infinity or near the either at infinity or near the lens, U will always be negative. U will always be negative. U will always be negative. This is the first point. Second point V. Whenever we are framing the image is obtained what? In front of mirror or in back of mirror? Everyone, V will be obtained where? Front or back? So V will always be negative. So V also will be coming as negative. Always. Note down please. The third one is focus. So always which focus we are using? Are we using the back side focus or front side focus? Front. So focus is also negative. So concave lens, all are always negative. Note down. So concave lens, U, V, F, all three will be negative. Understood? U, V, F, all will be negative for concave lens. Understood? So for concave lens, U, V, F, all part will be considered as negative. This part we have done. Now we are going to go for two cases drawing you can be able to do. Can I draw or you will draw it? You will draw. So now next first case, when the object is kept at infinity. So now we are going to understand about the nature. For doing the numericals, we must know this. So what will be U, what will be V, and what will be F? For convex lens, the back focal length always focal length we are taking. So focal length will always be positive. At the beginning, because of concave convex, I said focal length negative. Focal length will always be positive. And here U will be negative and V will always be positive. Remember this one? Come on, go for it. U will always be negative, B will always be positive, and F will always be positive. F will always be positive. This is the most important point. F will always be positive about convex lens. Huh? I hope everybody understood this one. Is it done? Are we going to go for the next part, beta? First, when the object A, first when the object is kept at infinity, where is the image obtained? What will be the magnification? Positive or negative? Now look here. Magnification formula is V by U. Understood? So when U is infinity, minus infinity, correct? Because image V will be obtained at what? Focus. This is focus distance. So here always remember कि whatever formula you are going to use, F focal length will be equal to V. In first case for both mirror and lens. In mirror part I have also discussed that time I have discussed a very important point, and that point was कि whenever an object is kept at infinity in front of concave mirror, focal length is equal to image distance. Focal length is equal to image distance. And magnification at that case was minus 0. Minus was representing real and inverted. 0 was showing that it is a very point size object, highly diminished. Understood? So now here F is equal to V. For convex lens also, F is equal to V coming. What is coming? Now here, magnification will be what? V by minus infinity. Correct? So that means it will come minus 0. Same as that of concave mirror. So negative is representing what? Real and inverted. And what is the next part? Highly diminished. Highly diminished. Understood? Good evening, sir. Good afternoon, sir. So look here, highly diminished. So now we are going to go for beyond. So when we are going to keep the object beyond curvature. So C1 is representing here as curvature point. What is C1 representing as? Curvature point. So when curvature point we are talking about, so in that part if curvature point we are talking about, what can be the answer here? So you need to check that. It will be in the second part. V is always positive here. V is also here positive. Now look here. Please check this part out. Here, solve one question. U is equal to, write down, minus 20 centimeter. Focal length is written as 8 centimeter. Find V if height of object is 3 centimeter. Magnification of the lens. Come on, everyone start solving this question, please. इन सीबीएसई बेटा फॉर्मूला प्रूव करने के लिए नहीं आएगा, सिर्फ फॉर्मूला को यूटिलाइज करना है. इन हायर क्लासेस इन सीबीएसई 12th ओनली ऑप्टिक्स में तुमको प्रूव करना है. Okay. According to our routine, from 6th we are starting maths, no? 6th, 6th morning we are starting maths. I will revision, correct? Because after that 6th night only, we will study chemistry. Only night. Yes. Comments upon matter. Acid basis is not huh? Biology also. Night part only, but morning part fully maths we will. Problem is 10th is also there. I will take care of 10th also. 10th people they are not, huh? 12th. See, look here. Now, can you give me the values, please? U was given as minus 20 centimeters. Focal length is given positive or negative? Positive, 8 centimeter. V we don't know. Magnification we have to find. Height of object is given as 3 centimeter. Length formula 1 by V minus 1 by U is equal to 1 by F. So 1 by V minus of minus 1 by 20 is equal to 1 by 8. So 1 by B is equal to 1 by 8 minus 1 by 20. So 1 by B is equal to 20 minus 8 by 160. B is equal to 160 by how much it is coming? 12. Correct? So B is coming as 160 by 12 centimeter. 100% the image will be obtained between F1 and F2 and 2F. Understood? F2 and 2F2. F2 and 2F2 in back side. So once B you are given, now magnification is see magnification is B by 160 by 12 and U is coming as minus 20. Minus 20 by 1. So 160 by 12 into 1 by 20. This and this will get cancelled. Minus. So here it will become 2 8s are. Then 4 2 is 8, 4 3 is 12. So magnification is minus 2 by 3. So negative means real and inverted. Less than 1 means diminished. Understood? Real, inverted and diminished. So now they are asking height of image. So height of image by height of object is equal to minus 2 by 3. So height of image was, height of object was 3. So it is coming as minus 2. So height of image is 2. So that means height of object is greater than height of image. So this is also representing. I hope it is done. Are you ready for the next one? This one noted, please note down fast. See, what is this? Did you finish? You wrote it? We'll go for next one, then what I'm waiting for. Now third case is when the object is kept at curvature. So we know that object distance will be equal to image distance. Here u will be equal to v. Whatever value of u will be there, same value will be v will be there. Here also magnification will be minus. So here magnification will be minus 1. Minus is representing real and inverted. 1 is representing size of image is equal to size of object. So this minus 1 is representing size of image is equal to size of object. So this is the most important part. Size of image is equal to size of object. So this part is done. Now next part is, see, this is at 2f1. Now here u is equal to v. Now when the object is kept between curvature and focus, so image will be obtained beyond curvature. Understood not? And same, all things will be same as that of mirror. Okay. Only diagram you have to remember. So when the object will be kept between at focus, image will be obtained at infinity. Image will be obtained at infinity. What will be the magnification in this case? Magnification part will be minus infinity. Minus infinity. Magnification in this case, when the object is kept at focus, magnification is coming as minus infinity. Object distance v will also be coming as infinity. So these two things are there. Whenever the object is kept at infinity, image will be obtained at infinity. Magnification will be minus infinity. Remember, magnification minus infinity means the image will be real and inverted, and size will be highly enlarged. The size will be what? Highly enlarged. The size will be highly enlarged. So now next part is, when somebody will be asking you when the object is kept between optical center and focus. So once the object is kept between principal, what will exactly going to happen? Here it will be obtained where? Beyond 2f1, it is virtual and erect. Magnification will be greater than 1. Magnification will be greater than 1. So we learned few things. In concave mirror, can we have a final analyzation? Difference between mirror and lens? So now let's have a final change. Concave mirror, okay, and convex mirror. Concave lens, convex lens. So when somebody will be asking you, concave mirror is having how many cases? 6 cases. Convex mirror, how many cases? 2. Concave lens is having how many cases? 2. Convex lens will be how many cases? 6. Here for concave mirror, focal length is always negative. Convex mirror, focal length is always positive. Concave lens, focal length is always negative. Convex lens, focal length is always positive. U is equal to negative. U here is negative. U here is negative. U here is negative. Here V will be negative for 5 cases. V is positive when the object is kept between focus and pole. Understood? Here V will be always positive. Here V will be concave lens. V will be always negative. Convex lens. V will be always positive. Correct? Except one case V will be negative. And only V will be negative when object is placed between F1 and O. F1 and optical center. So this is the proper analyzation. Here magnification will change. Magnification will start from minus 0 to magnification will come from positive greater than 1. Positive greater than 1. Correct now? Why? Because here it will start from very less real inverted and it will go to virtual. Virtual. Here magnification will always be positive and magnification will always be less than 1. Here magnification will always be negative or positive. For concave lens, magnification will always be positive or negative. Positive and always be less than 1. Image is always diminished now. For concave lens, image is always diminished. Here, magnification can be negative also and positive also. When magnification will be positive? Virtual and erect. And here, final case, between this case, and rest other it will be real and inverted. In both concave mirror and convex lens, size of image will increase. Size of image will increase when we go near the mirror or concave mirror or convex lens. I hope you might have understood. Concave mirror or convex lens. So this is some parts which we have to remember. Now after comes the what you call power of lens. We know that power of lens is what? 1 by f. Power of lens is 1 by f. And totally power of lens depends upon, the unit is diopter. 1 by meter is diopter. 1 by meter is diopter. 1 by meter is diopter. Remember, for power of lens, 1 by meter is diopter. 1 by meter is diopter. 1 by meter is what? Diopter. I hope you might have understood. So 1 by meter is considered here as diopter. So this is the end of lens. Refractive index we have finished. So all the different topics we have finished. Only last 2 set questions we are going to finish. So light chapter will be over. We finished chemical equations and reactions. We finished acid, bases and salt nicely. After that, which one we had to finish? Life process we have finished. Metals and non-metals we have to start metallurgy. One time metallurgy section I am going to keep. Environment chapter we have finished already, question answer sessions. Environment chapter MCQ you want now? Heredity MCQs can we do? Okay. So now, how was the session? I hope you people have enjoyed the session. We are going to start now maths for 12. Give me some break.